In this video, I'm going to demonstrate how to install Gentoo Linux with root file system encryption using UGRD, which is a tool I made to simplify creating an initrd for an encrypted root file system. I'm going to be following the handbook as closely as possible, and I recommend anyone that tries doing this, check these resources. Make sure you're using the most up-to-date information, and don't follow a video blindly without checking to see if there's any updates in any of the processes you should be using. For example, this page right here, it doesn't currently have information on using UGRD. It has Drake-cut information, it uses grub. And later I may actually add information on using UGRD here, as this page was mostly written by me. Okay, so to get started, the first thing you need to do is get your installation media. I usually use the minimal install ISO here. You can just download it here. I've already got it downloaded. If you're using not a VM, if you're booting on a real machine, you should probably write it to something that the machine can boot off of. USB is usually easiest. It's real simple to do that. You just use this dd command here, where the IF or input file is the minimal install ISO, and the output file is the device that you're writing it to. You don't want to write it to a partition, you want to write it to the base device like that. Once you do that, you should be able to boot it, and I will demonstrate by making a new VM here, selecting that ISO, and then pretty much everything else I'm just gonna make reasonable. Doesn't need much storage, doesn't need a whole lot of CPU because I'm going to be using a binary package host. So just like that, we're booted in. Press enter, select grub, and then when it asks for the keys, you can press enter if you're using a US key map. And it's going to prompt, here and say that you can set up SSH. I almost always recommend doing that. So it says here that you want to make sure the network is up, and then you can set a password and enable SSH. So I'm just going to run password, set a password of 1234. The password here will not be the password that's on your actual installed system. It's just for the live CD. And start the SSHD service. In most cases, if you have a DHCP on your network or IPv6, the networking should work, and you can run IPA and you can check your IP address, see if it was configured. Or you can ping something like Cloudflare a couple times and make sure you have an active connection. So that's working. Now that that is set up, whoops. I can SSH in, and I'd really recommend that if you're installing Gentoo, you do it over SSH. That way you don't have to type it in manually. You can copy and paste it from somewhere else. So with that done, we can move on to preparing the disks, and this is where things really deviate. This is pretty much the only point where things majorly deviate if you're using file system encryption. Because if you're not using encryption, you would make your root file system readable. Instead, and you put an actual file system right on the partition. When using LUKS, you want to create a container, which is your LUKS container, and then your partition is under that. Your root file system is under that. So to get started, you can see our main disk device here is VDA for a virtual disk. So let me make this larger too. You can open up that disk with fdisk. Type G to create a new GPT disk label, N to create a new partition, and we can accept the default partition 1, accept the default first sector, and then do +1G to make it 1 GB in size. Now I'm not using grub here, so I don't actually need a boot partition. I just need an EFI partition. So I'm going to label this partition I made as type 1, so T and then 1, so I label that as an EFI partition, and then I press N, and I can skip this section, so I just go here and then accept the defaults to make it span the rest of the disk, and then I can set the type of it, so T and then 2, and then I can set it to 23, which is a Linux root partition. With all of that done, I can write it with W. So with the partitions written, I can format VDA2 with LUKS. So I'm just substituting the device label there. Yes. Just setting it to 1, 2, 3, 4. And I would really recommend, if you're actually doing this, you back up your headers. This can be done after you boot, but if you lose your headers or if they get corrupt somehow, then all of your encrypted data will be completely irrecoverable. So it's essential that you make a backup unless you don't care about your data. So finally, with it created, we can open it. And you can just type open, it'll auto detect it. And then the last argument there is the name. Okay, now that's mounted, and then just got these commands copied here. Make fs for the first partition to make it a FAT32 partition, and then this mapped volume right here, root, we are going to make it btrfs formatted. So that's pretty much what's going on right here, except we're not doing the boot one. With that done, we can mount it. So we'll mount it to mnt gentoo. And then from here, we can pretty much continue with the gentoo install, as it says right here. So we can go to the stage tarball section here, installing it. We actually need to obtain it first. The way you do that is you just find the one you want. This is the one I need. Copy it. CD here, and you get it. So while that's working, I'm actually going to make another session here. And I'm going to continue with some of the install stuff. So after we download it, we're going to want to extract it, but we're going to want to copy our resolv.conf. And I'm going to be doing my portage configuration later. So this is the first thing we need to run. And we can extract this using just tar xf. You need these other configuration options here just to be safe if you're not using the minimal install ISO, but if you're using the minimal install ISO, you can just do rxf and then stage 3, and that should work. Okay, and while that's going, I can copy that and get ready to arch-chroot into here. So the first time you change root, you can use arch-chroot, and then the second time you can just change root right into it. So now we're in the change root, and it's helpful to set this right here. This just makes it indicate that you're in a change root, so you know you're not on the main file system. So and change root into this directory right here, and now we have 2 shells in the change root. Just add this here. Okay. And we can manually mount our EFI dir like this, or our boot dir similarly to this, but I actually prefer to just make an fstab entry right off the bat. And the way you can do that is you run block ID, which you run it normally, you get this output for all your devices, but you can filter it by whatever your ESP device is and then write it to your fstab. Once you do that, you can edit it and you can just sort of change the formatting here so it's a valid entry. And you'd want it like this. So first entry is the source, then it's the mount point, and then it's the mount type, which is optional. You can just do auto. And then no auto tells it not to mount automatically. So you have to manually specify that you want to mount boot. So with that done, you can just mount boot. And it's mounted. This step right here is not absolutely necessary. Gentoo will use the default repos if you don't configure it, but it doesn't hurt to do this. So you can just copy and paste those. And finally, we actually get our repos with emerge-webrsync. And while this is running, I'm actually going to run a couple of commands I have saved here just to pull some configuration files. And I can explain these real quick. So pull this make conf here, which is auto-configured, which has a couple of changes from the default one. I've increased the optimization level and specified the architecture as an architecture that both my build server and the target machine can use. I've enabled some use flags like PGO and LTO, which are optimizations, but they make build times way, way longer. I really wouldn't recommend doing these unless you actually plan to benchmark them and see if it's faster. It may or may not be faster depending on your system and if you can spare all the extra build time. And then this option here tells it to get binary packages. Then I have two bin repo configurations here. This default one is the default Gentoo one, and I'm just going to increase the priority here to make it priority 10 so it's used after this bin repo configuration I have here, which is using an internal server here to get packages from. Okay, so that's configured, and the last two changes that were made, I told gentoo-kernel to not use the init ramfs flag. That way it doesn't try to use drecut. And I set these for UGRD so it'll pull packages from Guru since they're all testing. Okay, now with that done, I can look at my merge profiles. The default one is all right, but we're going to be doing a gnome install, so we want to set it to this one. So we run eselect profile set, and we paste that. We could also put the number here. Of course, the appropriate number. Okay, now with that done, I'm going to pull some base packages here. I'm going to get eselect-repository, which we can use to enable the Guru repos, Git, which is what we want to use for the Guru repos, cryptsetup, which is used for LUKS, because it's not actually in the change root, it's on the install ISO, btrfs-progs for btrfs stuff, and efibootmgr to set our boot settings. And it's going to, or should be all purple here, because it's using, oh, I forgot one step, rather. We need to run getuto here, which will generate our portage GPG keys. You need to do this, especially if you're using binary packages. And I'm also going to be configuring portage to use Git for the Gentoo repos. At the same time, I add the Guru ones. So it's a couple steps here. I'll explain them as I go. Okay, so I'm going to merge the stuff again. Okay, select repository is enabled. So I'm going to first enable Guru. Then, according to this guide, I'm going to remove Gentoo once this is done installing. Then, just after I remove it, I enable it again. And now it's configured to use Git. And you can run this to get information about the repos. And we can see this is the location here. And there's currently information there which will not work with Git because Git doesn't want to override that information. So you should clear whatever is in that directory, which nothing there right now. So we don't actually need to clear it. And then finally, we can just sync. We're actually not going to run this. I'm just going to run emerge-sync to get the Gentoo repos and the Guru repos. And using Git to sync is just way faster than using rsync. Okay, so now back to the install guide. You can see we just ran that sync right there, so we need to do that. Should read the news like it says. I'm already aware of all this stuff, so I'm just going to continue. We set our profile already. This describes bin host configuration, which I already did, and this flag here, and it says to run getuto, which I failed to do earlier, but if you read the handbook, the information will be there. I've already set my use flags. I really wouldn't recommend digging too deep into this stuff if it's one of your first installs. This is something I'd maybe address after you have an install done, unless it's actually essential that you set these flags, which it may be if you're installing it on some sort of weird system or processor type. I'm in a VM. I don't need these Linux firmware files, so I'm going to skip this. Finally, you can just update the whole system like this. And in addition to doing that, I'm going to start getting UGRD. So you can just emerge it with emerge-UGRD. It's here. Ensure that those are all binaries. Okay, so now we have UGRD. Default configuration should work, but I've already tested and I know that I can remove these in a VM and I can add this right here, which will automatically add kernel modules required for a VM. So this only makes sense to do if you're doing this on a VM. I can leave that, it doesn't hurt. But what these will do here is the LSPCI one will read the hardware on your system and it'll pull kernel modules based off of that. And this one will pull all loaded kernel modules. So you essentially, if you leave both of these, your init-ramfs will be a little bit bloated, but it'll be pretty much guaranteed to work. If you remove these, then you pretty much absolutely have to set kernel module aliases here, or you have to ensure that the kernel modules required to boot are built into your kernel and aren't actually modules. If you want to add custom modules, you can just do kmod init equals, and then you can type in modules here. Like I could put in vfat, could put in whatever, kvm, so on. So these modules here, I'm going to comment this out. Take the same name as modules listed here, and UGRD will automatically do dependency resolution. So if you want a module like this one, it's not currently, I don't have a kernel built in the system. So I can't run mod info yet because I haven't installed a kernel, so. Pretty much, I'm skipping through the install here because everything's pretty much as we need it to get it booting. We just don't have like gnome installed. So here I'm installing gentoo-kernel. Now when I run mod info, it should show dependency information. Whoops. Need to set the kernel version. Plot repo. Okay. You can see here, it shows that's the virt.io module, and it shows the actual file. It shows it's built in, so it won't actually need to be imported. But that's just an example of how kernel modules work and how you can get information on them. But you just need to specify the one you need, and UGRD will pull in dependencies. You can see here, disk kernel installed successfully, which means that it installed UGRD correctly. And all we have to do to actually make our system bootable now is add a efibootmgr entry. So if we go to our ESP, we'll see there's these files here. This is our actual kernel, and then this is our init-ramfs that will be used to handle the decryption. So what we want to do is, you can see the help information with efibootmgr.help, but we just need to specify a new bootloader entry and give it the command line args for the init-ramfs. To do that, we do this: efibootmgr C to create D, and we describe the disk we want to install it to. It'll automatically do the first partition on whatever disk that is. We give it a label here, like gentoo, and then we specify the loader file. And if this is under some directory under your USB, you need to specify that directory, but you don't include the actual mount point under Linux. You treat this as if it's the root. So we specify the name of the file there for our kernel file, and then we do -u to specify command line options in Unicode, and we specify the init RAM disk. It's sort of an old option, but it's for init RAM fs2, and we specify the file name here. So we run that, and we see that it added successfully. The main boot option 4 is gentoo, and it has that file specified. Last thing you need to do is at least set a root password. If you follow the rest of the handbook, which I suggest you do if you're actually doing this, it will have information on all of this setup stuff here. So it'll have information on configuring your whole system here. So adding users, adding network stuff. But honestly, out of the box, all this stuff pretty much just works. A lot of this configuration is optional if you just have like DHCP. I would of course suggest setting a user. If you need to set key maps, you should do that. If you are using a locale that's not like an English locale, you should generate your locale. But if you're just using a pretty standard install that's just using pretty much defaults across the board, there's really not a lot you have to do. I would of course recommend setting things up like a syslogger if you're using OpenRC, because one's not included by default, neither is a cron daemon. But just for the sake of getting a system booted, I've pretty much done everything I need to do here. So exit and reboot. You can see back to the console here that it is rebooting. We can ignore those errors. So instantly, pretty much, it says press enter to start drive decryption. Type in my password, and we're booting. So that was the entirety of what UGRD is and does. Now we're logged in, and we can see DHCP is starting. So we're about to get info or address info, and now we're online. So at this point, we can just emerge GNOME, and it's going to start downloading all the packages needed for GNOME. And once this is done, we can just use our system as we'd like to with the GUI. But the tricky bit, which is getting the LUKS encryption going, is rather simple whenever using UGRD.